Edwin, well, he can't hear. I'll ask him to turn on his mic. Okay. Michelle, I'm wondering if he's having computer problems. Why don't you get started, Michelle, and we'll
Okay.
catch up with Edwin when he gets in.
All right. So we started our project. Edwin's actually supposed to do the first part, so I'm going to be a little off. So this project is supposed to expand the knowledge and understanding about the sewage system. It includes the rationale of wastewater treatment and the types and the process involved in sewage treatment systems. The process of testing water samples once it's entered into our waterways, the watershed, and testing the effluent before it enters the system. Edwin visited the sewage system in Newtown Creek in Brooklyn, New York. It's one of the, I think, 14 major water treatment centers in the metro area. And my aspect was to visit the Sauk Hill watershed community up in the Red Hook area, which is mid-Hudson Valley of New York. So let's change the slides. So we wanted to bring an urban and a rural aspect to the project. And I believe Edwin can take over.
Can you hear me?
Yes.
Can you hear me? Yes. All right, what slide am I now? All right, the learning target of the project, students would be able to explain the impact of technological development and growth in the human population on the living and non-living environment. This study expands knowledge and skills in the mastery of learning competencies identified in the New York State Living Environment Core Curriculum. Specifically, it targets K87, human decisions and activities have had a profound impact on the physical and living environment. In putting all theoretical articles in context, the team visited the New York Creek wastewater treatment plant in Brooklyn, the largest of New York City's 14 wastewater treatment plants. The lesson plan for this field trip targets the following standard and competency. The Common Core Standard. Conduct short research projects to answer questions including self-generated question, drawing on several sources and generating additional related focused questions that allow for multiple avenues of exploration. The lesson objective: explain the impact of technological development and growth in the human population on the living and non-living environment. So these are our findings and concepts gained. Pollutants from wastewater are being removed before it is released to local waterways. The wastewater undergoes major treatments. The first treatment is called preliminary. Effluent passes through, screened to remove large pieces of trash like rags, bottles, sticks, and the like. Followed by the primary treatment, allowing the heavier solids to settle to the bottom of the tanks and the lighter materials to float. Then the secondary treatment, wastewater is down further by adding air and seed sludge, which promotes the growth of aerobic bacteria, which consume organic matters. The final treatment in the process is disinfection. Treated wastewater remains 15 to 20 minutes in chlorine contact tanks to disinfect and kill harmful organisms. The effluent is then released into local waterways. Now I have Michelle, who is going to present the sewage system in the rural side.
Okay.
Go ahead, Michelle.
Yes, thank you. Thank you, Edwin. Okay, so I wanted to start the project with giving a quick survey to all the students, and it's actually in our website as well for people who just come to the website to take a quick survey of themselves, a quick audit, and to see what they're doing. So the survey is to ask them if they know what's in their water, what they're putting down their drain. Because basically we want to see from drain all the way to the watershed in the treatment process. So ask the question, what ingredients that are regularly go down the drain from the common products you use? If you do yes, no, what's the most influential aspect into you purchasing a product? Is it the hype or actual content of the product? And just have them and give them an example of like this Tide Ultra 2 detergent, how it contains the phosphates and how it's harmful even if you inhale it. So just to let them think about what they're actually putting in their clothes and into the water systems. And to take a quick note, since personal hygiene products, those are another big one, in the bathroom, personal hygiene products. That is known that teen girls use an average of 12 beauty and personal care products each day, while teen guys use 6, which I know in many high schools and middle schools, the Axe cologne is a little over the top. So that's a quick note, just a pre-water quality survey to get the students thinking about what their actions could possibly cause down the line. And because I live in upstate New York, it's more common for people to have septic systems as opposed to a sewage treatment plant. We do have one, but it's not for my town. It's for Dutchess County down near Poughkeepsie. So for rural settings, we have septic systems. And the septic system works essentially just like a wastewater treatment plant, less chemicals, but it removes solids. The larger solids sink to the bottom, and that's called the sludge layer. Soap, grease, and smaller solids form the scum layer on top. And in the middle, that clear liquid, as you can see in the picture, is called the effluent. It's clearish. It's between the sludge and the scum layers. And what helps is there's a lot of bacteria naturally occurring from waste in the septic system, and it's an anaerobic activity to decompose the solids and the liquids. This effluent is then released into a gravel bed, and where naturally pathogens are destroyed. The soil and different layers of dirt, the sand layer, the rocks, will naturally filter out and kill, supposedly, all harmful pollutants before it can reach the groundwater level. But septic system quality is a problem and can have major effects on our watershed areas, which can ultimately lead to major effects on our water quality. Like the group that said before us about the farmland using all the pesticides to keep their plants going and Miracle-Gro and fertilizers to enhance it, that all runs off as well into the watershed area. So our next slide is talking about the watershed. So what is a watershed? It's an area of land that catches rain, snow, drains, seeps into marshes, streams, lakes, rivers, and groundwater. And our project is to help students see how their water is used and that ultimately goes down the drain and affects the quality of the water that ultimately they can consume the next time around. Since for most areas, groundwater is taken from artesian wells, but the reservoir systems supply a lot of New York City waters, and that all has watershed within it. And it's also purified before it goes into the city. So I have pictures here of what the local Sawkill watershed area is where I live, and then also the Hudson River watershed, which reaches all the way up to Albany down to New York City. It's a pretty large portion of New York State. And then an idea of the Atlantic Ocean watershed, which is all of that area in red. And so we had the students do the survey beforehand and a lot of back work about what watershed is, what we put into our water, and what causes harm to the ecosystem in a watershed area. So the things we tested for at this site was dissolved oxygen, turbidity, nitrates, phosphates, pH, temperature, fecal coliform, and biochemical oxygen demand, the BOD, the water it needs to. And within our sites, our website, we have created a few Google Docs to capture the data. Because when the students first arrive to the watershed, you want them to take time to do a qualitative analysis of the area. Take pictures of what it looks like. Take note of the smell, the looks of the water. What color is it? What do they see on the edges? Are there rocks or is it cement? Or is there plants? Just get a whole idea of what is going on. So I have all of that in our website. So the students can take notes while they're in the field, but then fill it out and have a good basis to work off of. So, and everybody's working in the same form, especially when it comes to the chart for the results for the phosphates and the nitrates, to have it all in the same format. So it'll be easier to collect data over time. So students, from 10 years from now can look at the data and see if it's gotten worse or better with whatever inventions they have come up with, because ultimately we wanted to extend the project beyond just testing and seeing what's wrong with it, to get them to actually start thinking about, oh man, we're at the beginning again. Okay, there we go. Have them think about what beyond the lab report, and they should be writing about written results and the research, but have the students take all that knowledge and invent a mechanism that could help improve the water quality of the river in some way to prevent further pollution down in the river. Have them think hypothetically that they have tons of money, no bounds, and have them invent something, whether they draw it, create it, make it, design in AutoCAD, whatever they want to do, it's theirs. They write a report, of course, to put all of their qualitative and quantitative data, but this is taking it to the next step of them trying to make something more to better the system, and it makes them accountable. And also the students will then have the opportunity to share their findings and their inventions and their call to actions with the Sawkill watershed community. In our town, they have a meeting once a month, the first Monday of every month, where students would be able to go there, share their findings with the community and the town, and their call to actions of what could help improve the quality of the river and the watershed area and help create a better biodiversity and ecosystem. And for students to feel that the work is valued and can be important, that people are actually listening to them and they could actually enact a change, which is great. For funding, I know a lot of schools don't have the funding for such things, but the school district that I'm in has a Red Hook Education Foundation where they give grants for up to $1,000 per year to fund equipment, programs, and projects that are not funded or underfunded by the school districts. So you just have to fill out a form. But there's also the Regional Economic Development Council initiative, which can fund up to 85%. So through our website, we have a lot of links to get to information for funding and to find collaborators. Like I was able to find the Sawkill Watershed Community and Bard College, which has an environmental and urban studies department. And they would actually be working with the students as well at the Tivoli Bays watershed site to help them do collections, and it'd be more hands on deck and more people who were informed to help the students and educate them. And also the Dutchess County Wastewater Authority and local septic companies, which would always be willing to discuss how to maintain a septic system, how they pick a specific site, doing the percolation tests to see how the drainage is, and explain the whole process, which I think is very important. And then Edwin also got in touch with the Newtown Creek wastewater treatment plant and was able to do a site visit, and they also do tutorials there and show the students the testing, the processes that it goes through, and testing before the effluent is released into the waterways.
Well, Michelle, thank you very much. I think we're running a little low on time, so
Okay.
we're going to have to wrap up with you guys because we've got a little bit of a bumpy start there. But remember, each of you will be sharing your websites, and let's continue these conversations. You're all showing different models of how you can gather data across the state, which is quite elegant, or even locally, and you have given each other ideas and resources. So I hope this is just jump-starting a conversation that you'll continue on. And, you have through the web and email many ways to keep on communicating. So I'll ask, in the meantime, Sarah and Stephen to come up to the front. And thank you very much. As these guys know, I used to be a wastewater treatment chemist, so I was glad to hear of their work. And let's continue to meet after and share these ideas with people. And I thank you all for figuring out how to get the slides to turn. They're supposed to be in numerical order, but they seem to not be. But you're adapting well, and I'll move off stage so that I can try to get another tape going. But we're learning some fascinating things that I hope will continue to work with each other later, that this is only the beginning. So I'm going to turn my mic off, and Steve and Sarah are free to go whenever they can. And I'll be putting a note into the chat when your time starts running up. So you guys go ahead.